Hello, and welcome to Chemistry with Mr. Olson. Today we're going to solve a few problems from our Electrons and Ions worksheet. And to do that, we're going to need some notes we are putting or have put in our composition book. So this is on page 200 of our composition book, the periodic table. We have noted that the row of an element in the periodic table indicates the number of shells, the number of energy levels that are occupied with electrons, of course, in the ground state. So, for instance, hydrogen has 1 shell, beryllium has 2, iron has 4 shells. The other thing we have noted is the number of valence electrons. 1, 2, in fact, all the transition metals, including also the lanthanides and actinides, have 2 valence electrons. And then at this end, we see the number of valence electrons. Carbon has 4, nitrogen has 5, the whole nitrogen family. The halogens have 7 valence electrons, and the noble gases have 8 valence electrons, except for helium. So we can figure out, just by an element's position in the periodic table, how many valence electrons it has, and how many shells it has. The lanthanides have 6 shells. They slip in here between element 57 and 72. They're actually up there. And uranium, for example, has 7 shells. All right, let's answer some sample questions. Here is our worksheet. And let's start with question, one more thing to note. Electrons in the outermost shell are the valence electrons. All other electrons are core electrons. Therefore, the number of valence electrons plus the number of core electrons equals the total number of electrons. So, let's ask question number 13. What element has 6 valence electrons and 5 shells? So let's look. 6 valence electrons is the oxygen family, and 5 shells would be tellurium. All right, so that would be tellurium, Te. And one other one. 3 valence electrons and 4 shells. 3 valence electrons is the boron family, and 4 shells, we are talking gallium, Ga. There we go. How many valence electrons in the noble gases except for helium? That is, of course, 8 valence electrons. 8 valence electrons. And atoms become ions. We know that atoms become ions by gaining or losing electrons. And they want to resemble elements or get the electron configuration of the noble gases. Everybody wants to be like a noble gas with a full outermost shell. So let's do a couple sample problems. Let's do chlorine. Chlorine, number of shells. Chlorine has 3 shells from our periodic table. Total number of electrons, well, we're assuming a neutral atom. So chlorine is atomic number 17. So we have 17 electrons. I guess we should look here in atomic number 17. There's chlorine, 7 valence electrons, 1, 2, 3 shells. And 7 valence electrons. The number of core electrons, total minus valence, is 10 core electrons. The number of electrons in the nearest noble gas. Well, chlorine is, at atomic number 17, is between the 2 noble gases, neon and argon. But clearly 17 is closer to 18 than it is to 10. So, chlorine with 7 valence electrons will get 18. 18 is our nearest noble gas, and to get 18 from 17, chlorine gains 1 electron. So 17 plus 1, it gains 1 to get 18 electrons. And the charge of the ion, now it has 1 extra electron. So the charge of the ion is -1. There we go. Let's do one more. This time, let's do a metal. Let's do beryllium. Beryllium. The number of shells, let's take a look at beryllium. 2 shells and 2 valence electrons. And at atomic number 4, it's between helium with 2 and neon with 10. Alright, so answering the questions for beryllium, the number of shells is 2, the total number of electrons is 4, and it's got 2 valence electrons. 4 minus 2 is 2 core electrons. The nearest noble gas would be helium, so it's got 2 electrons, and it gains, it's a metal, and it will lose, it loses 2 electrons to get a total of 2, so the charge of the ion would be a +2. Let's jump down and answer question number 39. Question 39, an ion with 20 protons and 18 electrons. 20 protons, that's atomic number 20. That's calcium. And so it's Ca is the symbol, but we need the charge. And with 20 protons and 18 electrons, it has 2 extra protons, so a charge of +2, which we write as a superscript, +2. Okay, and let's answer number 47. Metal atoms, you'll note they are always losing electrons, so they become positive ions or cations. So positive ions, also known as cations. Nonmetals, since they gain electrons, they always become negative ions, also known as anions. Negative ions. And finally, let's predict the charge of sodium. With 1 valence electron, we expect it to get a +1 charge, and you can also see in that new periodic table we inserted in our composition book, it gets a +1 charge. The charges of the ions that elements form in the period that are shown in this periodic table, it is a very consistent pattern. +1, +2, +3 for aluminum and its family. From the nonmetals, 0 for the noble gases, -1 for all the halogens, -2 for the oxygen family, -3 for the nitrogen family. So a real pattern in the periodic table. And that is our help for today. I hope you have a lovely evening. Ta-ta.